Bismillahirrahmanirrahim. Assalamu alaikum to all of you. This is Abdul Ghaffar Abbasi here. Today we will discuss another topic of the chapter number 2, that is Charles law. First of all, introduction. This law was introduced by the Charles in 1787. Now what about the statement of this law? The volume of given mass of gas at constant pressure is directly proportional to absolute temperature, or in other words we can say that the volume of given mass of gas increases or decreases by 1 upon 273 times of its original volume at 0 degrees Celsius for every degree fall or rise of the temperature at given pressure. So according to Charles' law, the volume of given mass of gas at constant pressure is directly proportional to the absolute temperature. Now look at this mathematical derivation. Volume of given mass of gas is directly proportional to the temperature, that is absolute temperature, and pressure is kept constant. And when you remove this proportionality constant, you will place is equal to, and then K will be the constant, and then T will be at its own position. Now when you will rearrange this equation, here the T is multiplying, but when you bring T to at this side, it will divide. So that's why I have written here V divided by T is equal to K, that is constant. In other words, the ratio of V means volume of given mass of gas to its absolute temperature, that is T, is always constant provided the pressure is kept constant. So this is the explanation of this equation which we have derived from the mathematical representation or expression of the Charles law. Now we can change this equation into another form, like if V1 and V2 are the original and changed volumes, and T1 and T2 are the original and changed temperatures, then according to Charles law we can write it in this way: V1 divided by T1 is equal to K constant. At T2 we can write as V2 divided by T2 will be equal to constant. So we can rearrange and we can write it in this way, that V1 divided by T1 is equal to V2 divided by T2, that will be equal to K, means constant. This is the mathematical expression for the Charles law and used for solving the problems related to this law. Now we are moving to solve one problem related to this equation related to this law. Now another graphical representation of the Charles law: graph between volume and absolute temperature of a gas at constant pressure, that will be in a straight line. In this way, this will be the graph between volume and the absolute temperature. Now what about absolute temperature? Absolute scale of the temperature, or absolute zero. If the graph between volume and temperature is plotted, it intersects T axis at minus 273.16 degrees Celsius and at minus 273.16 degrees Celsius. So volume of any gas theoretically becomes zero, and that is indicated by this graph. So this is the we can say minus 273 will be called as the absolute temperature, and that is also called as the absolute temperature or the zero temperature, 0 degrees Celsius. So this is the graph related to the absolute scale. Now look at the main points related to this law. but practically volumes of a gas can never become zero. Actually, no gas can achieve the lowest possible temperature, and before the minus 273.16 degree Celsius, all gases are condensed to liquid. They will become liquid. So this temperature is referred as to absolute scale or absolute zero. This temperature minus 273.16. At minus 273.16 degrees Celsius, all molecular motions are ceased. There is no, we can say that, movement of the particles when this temperature is achieved. So this was the main points related to the Charles law. Now we are moving to solve the problem related to this one. A child's balloon has the volume that is 3.8 dm cube. When the temperature is 35 degrees Celsius, what is the volume if the balloon is put into the refrigerator and cooled at 25 degree Celsius? Assume that the pressure inside the balloon is equal to atmospheric pressure at all times. Now this is the problem related to the Charles law. How can we solve this with the help of the equation related to this law, Charles law? First of all, we have to make the data. Now look at here, original or initial volume V1 is mentioned in the question, that is 3.80 dm cube. Then temperature is also given, that is 35, but when we have to convert it into Kelvin, we have to add plus 273. This is very important key idea, that always you have to convert the degree Celsius temperature into Kelvin by adding 273. So this is 308, and pressure is the constant. And look at here, V2 is that is being asked. T2 is that temperature is 200, that is 5, and you have to convert it into Kelvin by adding 273, so that will be 278, and pressure is also constant. So now we have to put these values in the equation. According to the Charles law, V1 divided by T1 is equal to V2 divided by T2 is equal to K, constant. So if V2 is being asked, so we will write the V2 here, then V1 and this V1 will be here and T2 will be here, and then this T1 will be at this side. So this equation can be rearranged in this way. V2 is equal to V1 T2 divided by T1. So V1 is 3.8 dm cube and T2 is 278 and T1 is 308. So when you solve it, you will get 3.42 dm cube volume that is being asked in this question. In this lesson today we will discuss about the Charles law, introduction, statement and mathematical derivation, and some key points related to the Charles law. Then we discussed the one problem, we solved the one problem related to this equation. I hope you understood this topic. Thank you. Allah Hafiz.